Hello students. In this video we're going to look at question 1 on page 81 in your course package. Question states, a sample of 36 items is taken from a large population. The population has an average of 250 and a standard deviation of 30. And 4 questions following. The first one we're going to deal with is computing the standard error, and then finding the smallest interval that contains 97.36% of the sample means. Let's go here. So let's write down what we know. We know that the sample size is 36. It has an average of 250. And the population has a standard deviation of 30. We can compute this standard error. The standard error, if you remember, is the standard deviation divided by the square root of the sample size. So this would be 30 divided by the square root of 36. So the standard error would equal 5. That value is what we'll need for the rest of the question. So we're going to compute it first. Part B is asking for the interval, the upper level and the lower level, that would contain 97.36% of all sample means. So in this population has an average of 250. We want to compute the probability we want to compute the interval, actually, that would contain 97.36% of all possible sample means. So there's 97.36%. We want to find this interval and that interval, or that sample mean, lower level, and the sample mean on the upper level. So the first thing we need to do is take this 97.36% and divide it by 2, because it is on both the average, the mean, separates or divides that interval by 2. So 97.36 divided by 2 is 48.68%, or as a decimal, 0.4868. That value is going to lead us to a Z value, which will be both plus and minus, because we have a value on the lower end of the distribution and a value on the upper end of the distribution. So let's take this 4868 value, let's take it to the normal distribution chart that we have, and we're going to try to find 4868 in the middle values here and find a corresponding Z value for that value. So 4868 will be right there, 4868. So Z value of 2.2, and in this column 2. So the Z value would be plus or minus 2.22. We're going to be using this formula. Z equals the sample mean minus population mean divided by our standard error. So let's go to a new page. And we can use the Z value. 2.22 equals the sample mean, which is our unknown, minus the population mean of 250 divided by our standard error of 5. So we'll be left with a value of 261.1 for the upper limit. If we do this again, the only difference is we're working on the lower level, lower end of the distribution, so the Z value is going to be negative. This part of the formula is the same, and we divide by our standard error. We're going to get a value of 238.9. This would relate to, or help us understand, that 97.36% of all possible sample means with a sample size of 36 would be between this upper limit and this lower limit. So 97.36% of all possible sample means of size 36 would be between 238.9 and 261.1. Third question here is to determine the probability that the sample mean will be between 243 and 257. So question C is asking for the probability, whereas part B was asking for the interval being the two x values we have here. So the determining the probability, we want to get an answer like this. When it says to find the smallest interval, this is basically what we're doing. So let's determine the probability that the sample mean will be between 243 and 257. So first of all, let's draw out the distribution. It's always good practice. There's the average, 250, and 243 is down there, 257 is up there. We want to determine all of that area, or that probability. We know from the previous question that the standard error equals 5. So we're going to be using this Z formula, same one we've been working on. Oops, not divided by 80. Sorry, I was getting ahead of myself. Divided by our standard error. So we can calculate Z. We're going to use, would be two Z values, one for the lower limit, one for the upper limit. Z is going to be 257 minus 250 divided by 5. So Z is going to equal plus 1.4. If we were to do that for the lower end value, we would get Z would equal 243 minus 250 divided by 1.4. Sorry, divided by 5. Z value is going to be negative 1.4. If we look at the area, the second step is taking that Z value, and they're both same value, just that one is negative. So we look at the area that corresponds to Z value 1.4. We look at our normal distribution chart. Z value 1.4 and 1.40, so the area is 4192. So let's write that here. So the area is 0.4192. That area corresponds to this section in here, 0.4192. The Z value of negative 1.4 would also correspond to an area of 4192. So the total area we get, we add them together and multiply 1 by 2. We get an area of, and our final answer, 8384. So approximately 83.84% of the sample means should be between 243 and 257. Now we move to our last question on this, last part of this question. It is to determine the probability that the sample mean will be more than 242. So we're trying to calculate the probability that it is going to be more than 242. So let's go to this. Let's draw out our normal distribution. Average is 250. It has a standard error of 5. And we want to know the probability that it is more than 242. Let's put 242 right there. And we're going to shade in all of this area here. So this goes back to questions in chapter 5. So let's take a look at how we would do this. We'd calculate a Z value. Step 1 is calculating a Z value for the sample mean. We're using this formula here, divided by the standard error. So 242 minus 250 over 5. Z value is going to be negative 1.6. We're going to look at, find the area that corresponds to that Z value 1.6. The area is 4452, right in there. So we know that the area, step 2, is 0.4452. this area corresponds to that section in here, from the mean to the sample mean area, or sample mean point. To get our final answer, we want to know the probability that it is more than 242. So 242 all the way to the right. We know that it's going to include 0.4452 on the left side, but it's also going to include this value here. It's everything on the right side of the mean, so that's going to be 0.5. So our final answer is going to be 0.4452 plus 0.5, so 0.9452, which corresponds to approximately 94.52%. So there's a 94.52% probability that a sample mean will be $242 or more.